Okay, we're going to do numbers 1 to 4 from the arc length worksheet. These are sample problems 1 to 4, and you could just scroll down and they show you all the work, but I'm just going to be explaining what's actually happening. So before we even start, let's talk about what we're doing. So integrals are used to find infinitely small things and add them all up. In this case, now we actually want the curve, so how long the curve is. And to figure out how long the curve is, we like to take very little slopes, little slope here, all along the curve. And then we're just going to add up all the tiny slopes at an infinitely small thing. Now, when we're talking about curves of a slope, we have to refer back to something from chapter 2-3, which is derivatives. So we have to take all those derivatives back. Now we're going to take the derivative. Now, the important thing is that there is a equation for this. And I don't want to spend too much time talking about what the equation is itself. And I just want to make sure equation, I know what it is. It is, why is this not working? This equation is the integral of 1 plus the derivative, or f prime you could do, or dx dy squared. And where's my eraser? Yes. So the equation, and this is the equation that matters from B to A. 1, is it plus or minus? I gotta remember. I'll put it in the after. But f prime of x squared. So whatever your prime of this equation is, squared, dx. Okay, so that's the equation. I just gotta remember if it's a plus or minus. Let me just look at that real quick. Integral. Plus, okay. Just want to make sure. All right, so we have that. So then what we're going to do is use it for the, I don't know why my thing went like that. Use it for this equation. So this is our first f of x. 2x minus 1, 3 halves. So we have to find the f of prime of that. So we're going to have to find the f of prime of that. So we got to remember our derivative rules from like 3 chapters ago. So when you have a derivative, you got to use the chain rule. So it's going to be 2 on the outside. The inside stays exactly the same. Now this integral is going to go down 1 level. So it's going to be 1/2. You remember you subtract 1, we derive. Right? And then this new thing is you're going to multiply the new thing in front. So you're going to multiply the new thing in front, which is times 1/2. But because this was not just x, we have to do the chain rule. So the chain rule here is the derivative of this inside. And the derivative of this side, this is just x to the 1, so that reduces to 1. And then this is minus 1, that becomes 0 when you derive a constant. And then we could just clean it up a little bit by simplifying some things. 2.5 cancels out. So we're left with x minus 1, and times 1 doesn't change anything, to the 1/2 power.
I have a question.
Yeah.
How come we moved down 1/2 power instead of 3/2 power?
Maybe I messed up. Maybe I don't remember my integral rules. Do we only move down 3/2 powers? Oh yeah, that's right. You only put the new one in the integrals. Thanks for the help. So let's just fix this a little bit. So technically this should be 3/2 in front, because you bring the old one. These two still get canceled out. And then we're just left with 3 here, so there should be a 3 in front. Just like that. Still, everything should be copacetic from this situation on. I'm trying to just make sure. Okay. But remember, in the equation, we need the square of this thing. So we actually want to know what f prime squared is. So that means I'm going to square everything here. So I'm going to square everything here. I guess I could just rewrite that square root x squared. Okay. Thankfully, they're multiplied to each other. It's not added or subtracted, so we could just square them out. So 3 squared, we could just distribute the squared. So 3 squared is 9. And then the square root of x minus 1 is just x minus 1. And then I could distribute at 9. So 9x minus 9. So this right here, 9x minus 9, is my function from f squared of f squared of f. And I made a mistake on the original equation. This whole thing's square root. I knew it was too easy. This whole thing should be square rooted. So that'll make our math a little bit more annoying, but not too annoying. Okay. See if I can make this a little smaller for myself. What the? Okay. Right. So we did all that work just to find f prime x squared. So now let's plug it into our equation. From a to b, the square root of 1 plus 9x minus 9 dx. And combine a little like terms, the square root of 9x minus 8. Or, yeah, minus 8. Now, oh, and we know what a and b is. I'm sorry. A and b is going to be from 1 to 5. Now, as I said earlier, you're free to use your calculator on this. So after you get to this point right here, let me rewrite here, 1 to 5, 9x minus 8 dx, you could type into your calculator. The worksheet and all the other examples are making you do it by hand, but we already done 2 tests on the integrating and stuff. I'm going to trust you know that. And in that case, you could just slap into your calculator, and you'll be done here. Okay? At least get to here. Okay? Any questions on that one, or can I go to number 2? I'll leave it up there because these people still copying. I'll start number 2 over here. Okay, number 2, again, our equation is still the same as that red part. Our f of x just changed. So f of x is x cubed divided by 6 plus 1 over 2x from 1 to 3. Okay, so we're on number 2. Oh, I guess I could do it like that. I already have the picture. Okay, so the first thing you have to do is find your f prime of x squared. So first, before you could do that, let's find fx of prime. So you times the original number, and then you subtract the 1 and 1. So it's 3x to the 2nd power over 6 plus this one over here. This one over here, that's technically 1/2 times x to the negative 1. So in order to change that, we're going to bring down the original negative 1, so negative 1/2, and then we're going to subtract it by 1, so that's x to the negative 2 now. This could simplify to a half up here, x squared, plus this is simply 1 over 2x squared. Now what's interesting is we could factor a half out because it happens to both of these have halves. X squared. Actually, do we want to factor it out? I guess, well, we're going to have to square it, so maybe factoring out is not that useful. Oh, yeah, maybe factoring not as useful. So x squared plus, I'm sorry, x squared minus 1 over x squared. Okay. Can I erase the first one? Anyone has any objection to erasing the first one? So I have a little bit more space.
I'm still on the first one.
Yeah, go ahead then.
Were we only supposed to do the odds?
No, I said 1 through 4.
Oh, okay.
Okay.
Because this one's number 3.
Is this number 3? Oh, I went. Okay, so we'll call it we'll do number 3 right now then. Let me finish number 3. I went left to right. My fault. Okay. So we have a half minus x squared and a half. So we should square this. So we're going to square this whole thing because we're looking for f prime squared. So we're looking for f prime squared. Let me change my ink. So we're looking for f prime squared. So let's square all that. So this whole thing is going to end up being squared. The 1/2 basically just becomes 1/4. That's really nice. But this part right here, we're going to have to force the FOIL. So you remember the rule is a squared plus, I guess it's negative, so it's minus 2ab plus b squared. So let's put a parenthesis. A squared, a is the first term, so that's x to the 4th. X to the 4th, I don't know why I wrote 2. Minus 2ab, so 2ab, so that's 2 times a half x squared times a negative, or the minus already takes care of that, 1/2. So these two ends up canceling out, so it's just a 2 in here. And then plus b squared, so that's just 1 over x to the 4th. Okay. Is there anything else we could simplify this by? Guess we could distribute the 4th now. So we got x to the 4th over 4 minus a half plus 1 over 4x to the 4th. Okay. So all that is my f prime of x squared. So we're going to put it into this original equation over here. So the integral of a to b is, I know what a and b is, I don't know why I keep writing that. So the integral from 1 to 3, and we get that from the original problem, is the square root of 1 plus all of this. To make it a little easier, I'll just combine like terms. So the 1 will end up becoming a half. So I'll write it in correct order. X to the 4th over 4 plus 1 over 4x to the 4th plus a half, because the 1 and the negative a half combined. At least get to that far in your hands, and then we could just use the calculator from there. I just want to make sure we put it in correctly. Oh, and they're solving it by hand on this one. Okay. All right. I'm going to erase number 1, and then we'll go.
I'm good if you need to erase number 1.
Fine. So erase number 1. I don't want to actually delete my equation. So let's keep it. And I'll keep number 2 up there. So we're going to do number 2 now. Actually, number 2. Number 2 is flip over here. Number 2.
I typed it in wrong on the calculator, but I got something else, a different answer. What did everyone?
Did you just say you typed it in wrong?
No, I don't know if I typed it in wrong. I'm checking my parentheses, but I was wondering what everyone else got to make sure that they got it.
I'll pull out my calculator. Let's see. Let's see. Okay. I know, first thing is the equation. So the square root of x to the 4th divided by 4 I have to put another parenthesis. Plus 1 over 4x to the 4th. If you did make an error, make sure that the 1 over 4x to the 4th, that the 4 is definitely in the denominator in your calculator. Plus a half. X, deriving based off x from 1 to 3. I got 4.67 repeated. That's 14 over 3, yeah.
Yeah, I got that too, but then the answer. Oh wait. Oh, I was looking at the answer for 2.
Oh,
Oh gosh, my bad.
okay. We're just going on. Number 2.
My bad.
Number 2 is 2/3 x squared plus 1 to the 3/2 power from 1 to 4. Okay, so we're going to use that equation on top in the red. So before we can even use it, we need to find f of prime of x, and then from there we're going to find f squared. So the prime, 2/3, it's in front because it's multiplied, it doesn't disappear like that. We're going to move this one down, so that's 3/2. Very convenient, some might say. X squared plus 1 on the inside. This is reduced by 1/2, times you have to take the derivative of the inside, so that's 2x. You can't forget that part. So you got to take that 2x. Well, these all cancel it out. So your f prime is just 2x in the front, x squared plus 1 to the 1/2 power. You could put in a square root symbol if you wish. But regardless, we're going to have to square it anyway, because that's f prime of x. We want f prime of x squared. Let me start using a different color. Now we're going to square this whole thing. So 2x squared is very simple. It's just 4x to the second power. They're being multiplied, so you could just distribute the square. Now this over here, this half, the square root and the square cancels out. So it's just simply x squared plus 1 in parentheses. And I could distribute that 4x squared. So that's 4x to the fourth plus 4x to the second. Okay, I'm going to start erasing this top of number 3. So we're there. Now we're going to take and plug it into our original equation. So that's supposed to be the square root from the integral of 1 to 4 of 1 plus, there's nothing to combine like terms, so 4x to the fourth plus 4x to the fourth plus 4x to the second plus 1. And you could kind of notice here, this question is purposely, this is perfectly a different, some power of square. So it's possible to do it by hand. But again, I don't need you to do it by hand. So we should have set it up like that. You know, do all your work to slap it into the calculator, and you should get it. And I'm just going to check the solutions to see if I'm not that off. Yeah, it looks like they agree with me. Okay. So that's number 3. And we're going to, or that was number 2, my bad. That was number 2. And now we're going to do number 3. Or number 4. I'm getting all my numbers confused. All right. So last one, ln of cosine x. Oh, now we got to remember some real derivative rules. From 0 to pi over 4. If you're going to use the calculator, make sure to use the actual symbol pi. Don't just use 3.14, especially when it comes to like integrals and stuff. This one though, in the calculator, I don't think you won't get your value. So, or I guess you'll get a decimal value. The worksheet, they give you it in terms of ln, which if you were doing by hand, I would expect it in the terms of ln. Okay. So ln of cosine x, 0 to pi over 4. So we're going to derive it to get our things. So we're going to derive it. So the f of prime x. Now the derivative of ln, I believe, was u prime over u. No, I'm sorry, u over u prime. No, it's the derivative of the inside. So it's 1 over whatever this is. So this is 1 over cosine. Times it's the integral of cosine, or the derivative of cosine, because it's u prime. And I'll just write this here. ln is the u prime over u. So then the prime of cosine is negative sine. So we have negative sine x over cosine x. Sine over cosine, that is not tangent, but cotangent, I believe. Or is that tangent? Somebody help me out. Is sine over cosine tangent or cotangent? Is it tangent?
I think so.
Y over x? Yeah, that makes sense. Yeah. Okay, so that's negative tan, though. Negative tan x. Well, that's f of x. But remember, we got to square it. So the negative tan x times negative tan x is going to be a positive tan x squared. Or tan squared x, I guess, more correct. Yikes. F of x. So that's our derivative. And then we put in our integral from 0 and pi over 4, the square root of 1 plus tan x, tan squared x. If you do use your calculator, I think you have to make sure it's in radians, or it won't pop up correctly, or you won't get the right answer. Pi over 4. That's over pi over 4. If you were doing this by hand, I guess you could. It says a property. Yeah, you could change it to something else. But that should be your setup right there. And I'm just going to check the worked out solutions to see if that makes sense. Oh, and they use the trig identity to change it to secant squared x, which then you could reduce it down to, so to make your inside your, and I should ask you to simplify as best as possible. So the inside of your integral is just the integral of secant x, because you can simplify it that much. Yeah. But I should ask you to get to at least this piece right here on the bottom.
Quick question: how do you type in a secant squared on a calculator, like the squared part?
You type secant x, close parenthesis, then square it. So square it on the outside of the parenthesis, not the. It won't look like secant squared x. It'll be secant x, all that squared, essentially. And then to check your answer, just also type in ln, the square root of 2 plus 1. So you could check if they were the same decimals. But remember, though, the secant squared x disappeared. So you're literally just integrating secant x. You don't need secant squared x.
Why does it disappear?
Because it's this trig identity becomes secant squared x, and then the square root of a squared is just itself. So it's just secant x. It shouldn't be secant squared x. And your calculator might not have secant button. It'll just have cosine minus 1, I imagine. So just make sure you do cosine minus 1. Comma x, comma, from 0 to. And the pi button should be above the power, so the bracket, above division.
Would you be able to show me your calculator so I can see how it
Sure.
looks?
It's not going to look as nice as yours, but oh, did I forget to put too many parentheses? Okay, and then let me just, I just want to also do the ln. Ln of the square root of 2. Let me say minus 1, plus 1. Oh boy, we'll see. So I'll show you my calculator. And I'm going to make sure I typed it in correctly. The opposite side. Go ahead.
I wrote it wrong myself, but your calculator just triggered an idea. I think it's 1 divided by cosine x instead of like cosine to the negative 1, like the inverse of cosine.
Ah, thank you.
Kind of like this, right? Right.
I can't really see it. It definitely should be 0.88. That ln is definitely the correct answer. So let's see if that fixes it. So 1. Insert the divided by cosine of x. Yeah, that fixes it. Thank you. I appreciate that. Yeah, that's right. Cosine of -1 is inverse cosine. So you got to do 1 divided by cosine x. Then you know it. So yeah, so then you can see compared to the 2 decimals, there's the right answer. So we got it right. Yep, that's all 4 of them. And let me just pull back the whiteboard. So if anyone still needs to copy anything, it's there. But that should be it for the homework today. So make sure to take a snapshot and then post it so you don't have to worry about it.
Thank you.
No problem.
Have a great day.
You too.
Thank you.
No
Thank you.
problem.
Thank
Hey, no
you.
problem. Uh-huh.